sklearn, discriminant analysis, linear discriminant analysis. A detailed explanation. Linear discriminant analysis (LDA) is a powerful classification technique used in machine learning. The sklearn, discriminant analysis, linear discriminant analysis class in scikit-learn provides an implementation of LDA, allowing you to build classifiers for both binary and multi-class problems. Key concepts. 1. Dimensionality reduction. LDA aims to reduce the dimensionality of the data while maximizing separation between classes. It achieves this by finding the linear combinations of features that best discriminate between classes. 2. Bayes theorem. LDA relies on Bayes theorem to estimate the probability of a data point belonging to a specific class. It assumes that the data in each class follows a Gaussian distribution. 3. Linear decision boundaries. LDA creates linear decision boundaries in the feature space to separate the classes. These boundaries are optimal in the sense that they maximize the distance between class means while minimizing the variance within each class. Implementation in scikit-learn. The sklearn, discriminant analysis, linear discriminant analysis class provides a comprehensive set of features for applying LDA in your machine learning projects. Initialization parameters. Solver controls the method used for solving the LDA problem. SVD singular value decomposition default. Robust for singular matrices. Eigenvalue decomposition. More efficient for small data sets. LSQR least square solution. Good for large data sets. Shrinkage controls the shrinkage applied to the covariance matrix, enabling regularization and improving robustness. None default no shrinkage. Automatic shrinkage based on Leduit-Wolf shrinkage estimator. Float specifies the shrinkage parameter. Prior probabilities of each class. By default, it uses the empirical prior probabilities. You can specify custom priors as an array. N components, number of components to keep. By default, it keeps all components. Reducing the number of components can lead to dimensionality reduction. Stochcovariance, whether to store the covariance matrix. Set to true if you need access to it later. Tolerance for singular values. Used for numerical stability. Covariance estimator function used to estimate the covariance matrix. Methods. Fitx. Y fits the LDA model to the training data. TransformX applies the LDA transformation to the data. This method projects the data onto the discriminative subspace, reducing its dimensionality. PredictX predicts the class labels for new data points. PredictProbX returns the predicted probabilities of each class for new data points. ScoreX. Y calculates the accuracy score of the classifier on the given data. Benefits of LDA. Fast and efficient. LDA is computationally inexpensive and relatively fast, making it suitable for large datasets. Interpretable. The discriminative directions obtained by LDA can provide insights into the features that best separate the classes. Robust to outliers. The use of covariance shrinkage can improve the robustness of LDA to outliers in the data. Limitations of LDA. Assumption of Gaussian distribution. LDA assumes that the data in each class follows a Gaussian distribution. This assumption might not always hold, potentially leading to suboptimal performance. Linear decision boundaries. LDA can only create linear decision boundaries. This might not be appropriate for datasets with nonlinear relationships between classes. Sensitivity to class imbalance. LDA can be sensitive to class imbalance. If one class has significantly fewer samples than others, the classifier may be biased towards the larger class. Applications. LDA is widely used in various domains, including Face recognition identifying individuals based on facial features. Spam detection classifying emails as spam or not spam. Medical diagnosis classifying patients based on medical data. Image classification categorizing images based on their content. Example: Python. From sklearn, discriminant analysis import linear discriminant analysis. From sklearn, datasets import load iris. From sklearn, model selection import train test split. Load the iris dataset. Iris load iris. X iris. Data. Y iris. Target. Split the data into training and testing sets. X train. X test. Y train. Y test train test split X. Y. Test size 0.2. Random state 42. Create an LDA classifier. LDA linear discriminant analysis. Fit the model to the training data. LDA. Fit X train. Y train. Predict the labels for the test data. YPRED LDA. Predict X test. Calculate the accuracy score. Accuracy LDA. Scores test. Y test. Print F accuracy 0.2F. This example demonstrates how to use linear discriminant analysis to build an LDA classifier and evaluate its performance on the iris dataset. Further exploration. For a deeper understanding of LDA and its applications, you can refer to the following resources. Scikit-learn. Documentation https://scikit-learn. org stable modules generated sklearn. Discriminant analysis. Linear discriminant analysis. HTML. Wikipedia article on linear discriminant analysis https:// Wikipedia. org wiki linear discriminant analysis. A practical guide to linear discriminant analysis https machine learning mastery.com linear discriminant analysis for machine learning. Remember that LDA is a powerful tool for classification, but it's crucial to understand its assumptions and limitations to apply it effectively in your machine learning projects.